You ever hit play on a new episode of a huge show right as it drops and wonder how millions of other people are doing the exact same thing without the whole thing just crashing? Well, it is definitely not magic. It's an incredible story about software architecture, and we're going to break down exactly how Netflix did it.
Okay, just to set the stage here, get your head around this number. At any given moment, Netflix traffic accounts for about 15% of all downstream internet traffic, globally. That is a literal tidal wave of data flowing to millions of screens every single second.
So the big question is, how is that even possible? How can one service possibly handle that much load without just completely collapsing? The secret isn't just about having more servers, it's about a completely different way of thinking about how you build software.
To really appreciate the genius of what Netflix is doing now, we actually have to go back in time. See, like a lot of tech companies, they started out with a pretty traditional system, a system that eventually became a massive wall standing in the way of their growth.
This old way is called a monolithic architecture. The best way to think about it is like a giant restaurant kitchen, where every single piece of equipment, the grill, the fryer, the prep station, all of it is physically bolted together. It's all one single, giant, interconnected machine.
And you can probably guess that that kind of kitchen model just does not work at internet scale. If the fryer breaks, the whole kitchen grinds to a halt. If you want to upgrade the oven, sorry, gotta shut down the entire restaurant for a week. For a company like Netflix that needs to be constantly changing and improving, this monolithic wall was a huge, huge bottleneck.
So Netflix made a radical change. They decided to take a sledgehammer to that giant kitchen. They broke it apart into dozens and dozens of smaller, specialized stations that could all work totally independently. And this, right here, was their big architectural breakthrough. And the difference? I mean, it's night and day. On the left, you've got the monolith, that one giant tangled block of code. But on the right, you have microservices. It's a collection of small, independent services. Each one has just one job. One handles billing, another handles your user profile, another does search. They can talk to each other, but they are not bolted together.
So you're probably wondering, how do you manage all these separate parts without it turning into chaos? Well, the first key player is the API gateway, which Netflix built and called Zool. Just think of it as the ultimate traffic cop. It stands right at the front door, it sees every single request coming in from your phone or your TV, and it instantly knows exactly which microservice needs to handle it and sends it on its way. Okay, but what about the services talking to each other? That's the next piece of the puzzle. They use an amazing system called Kafka. The easiest way to picture it is like a central company message board. So when one service, let's say the watch history service, has an update, it just posts a message on the board that says, hey, user 123 just finished this episode. It doesn't know or care who reads it. Then other services, like the one that gives you recommendations, are subscribed to that board, and they see the message and go, oh, I should act on that. This idea of decoupling is absolutely crucial for building a resilient system that can scale. All right, so let's zoom out a bit. This entire Netflix architecture is basically split into two huge parts. You've got the control plane, which runs on Amazon Web Services. That's the brain. It handles everything non-video, logging you in, searching for a show, figuring out what to recommend. And then you have the data plane. That's the muscle. Its only job is the heavy lifting of actually getting the video files to your screen.
So here's how it actually works when you sit down to watch something. The second you hit play, your device sends a request to the control plane, the brain, in Amazon's cloud. The brain checks your account, figures everything out, and then uses its own massive global network of servers called OpenConnect to find the one server that's physically closest to you that has the movie you want. Then it tells your device, hey, go talk to that server directly. The brain makes the decision, and the local muscle delivers the video.
And the real game changer in all of this is speed. Not just streaming speed, but development speed. Because everything is decoupled, you can have hundreds of teams working in parallel without stepping on each other's toes. The team working on search can push updates 10 times a day, and it will never, ever interfere with the billing system or the video player. This just unlocks a crazy pace of innovation.
Okay, let's make this more concrete. I want to show you a perfect example of just how powerful this approach is. We're going to look at one specific microservice that solves a really, really tough problem: how to measure video quality.
So Netflix is constantly creating new, better ways to compress video so you get amazing quality using less data. But here's the problem. How do you know if a new algorithm is actually better? The only way to know for sure is to test it. But re-encoding their entire, unimaginably massive library of content every single time, that would be crazy expensive and would take forever.
They needed a smarter way. And their solution is a thing of beauty, the Video Quality Service, or VQS. Since it's a microservice, it can work all on its own. It takes a video file, slices it up into thousands of tiny little chunks, and then, and here's the magic, it uses their massive cloud infrastructure to process all of those chunks at the exact same time, in parallel. So instead of one giant job that takes hours, it's thousands of tiny jobs that take seconds. Then it just reassembles the results into a final score. It's a brilliant way to use their scale to speed up innovation.
Now we get to my favorite part. It's the most counterintuitive and maybe the most brilliant part of the whole Netflix philosophy. See, they don't just hope their system is reliable. They actively try to break it all the time to make it even stronger.
This whole discipline has a name, chaos engineering. And the core idea is simple but powerful. The best way to prevent huge, catastrophic failures is to constantly create small, controlled failures. It's kind of like a vaccine for your software. You introduce a tiny, harmless version of the problem to build up a powerful immunity.
And their most famous tool for doing this is called Chaos Monkey. It is literally a program whose only job is to run around inside their live production system and randomly shut down servers. Just poof, gone. This forces every single engineer to design their service with the assumption that things will fail. They have to build for resilience from day one because they know Chaos Monkey is always out there lurking.
But, and this is super important, it's not just about mindlessly breaking things for fun. As the quote says, it's way more subtle than that. It's about running carefully designed experiments to learn how your system behaves under stress. This whole philosophy just completely flips the old IT mindset on its head. Instead of trying to prevent every single failure, you accept that failure is inevitable and you use it to build a system that is fundamentally stronger.
So, what's the end result of all this? When you combine microservices, this idea of decoupling, and this philosophy of designing for chaos, what do you actually get?
Well, you get some pretty incredible benefits. A new season of a hit show drops. The system scales up instantly to handle the load. One of those hundreds of services has a weird bug? No problem. The rest of the site stays online, and things just degrade gracefully. And their engineers can move at lightning speed, deploying new code constantly, because the entire platform is built from the ground up to expect and absorb failure. And at the end of the day, that is the real magic of this whole design. As a user, you never see any of this. The hundreds of microservices, the chaos monkeys running around, the massive global network, all of that unbelievable complexity is completely hidden behind one simple, incredibly smooth experience of just hitting play.
It really leaves you with a final thought, right? This entire philosophy of embracing failure, of decoupling systems, it's not just about streaming video. If you can build a complex system that actually thrives on chaos and gets stronger from it, what other impossible problems could we solve with that same mindset? What else is suddenly within our reach?